Here we go. Let's remind you again how to rewrite. These are basic logarithms. A logarithm can be written in exponential form. A logarithm can be written in logarithmic form. Back and forth. That's one of the most important things. Like I told you, one of the most important things that you can learn about these logarithms. Again, the base of this log. Well, you tell me, Seth. What is the base of this log? 5. The base of the log, the way I remember it, the base of the log is the same thing as the base of your exponent. So here, 5 raised to the, whatever the log is equal to, is your exponent. So this would be 5 to the 4th power equals 625. That'd be pretty easy to check yourself on that, whether you have it in the right form because you've got numbers there. And we know 5 to the 4th power does give you 625, so that's a pretty easy way to check that. Another one, again, base of the log, base of the exponent. Raised to the number on the other side of the equal sign equals n in this case. That's your first glimpse of some of the equations we're going to have to solve. If you got log base 3 of n equals 5, and you're trying to figure out what n is, just rewrite it. Look what you got. N is 3 to the 5th power, which is going to be, I think, 243. So now you've got your n. So here in a little while, we're going to be solving logarithmic equations. They're not too bad. 3 to the x power equals 50. Again, we're catching a glimpse of what we're going to be using this for. It says rewrite this in rewrite each exponential form in logarithmic form. So 3 to the x power equals 50 would be log base. I'll let you help me, Michaela. Log base, base and base of the exponent goes on the other side of 50. So x equals log base 3 of 50. So again, think about ACT. If you were asked to solve this equation, what is x equal to? There you go. X equals log base 3 of 50. Now later on in the chapter, we'll learn how to turn that into a decimal. Okay, because remember, we can't plug this in. We can't type that into our calculator. We can only type in 2 different types of logs in our calculators. Remember what those are called? Common and natural. Log base 10, log base e. That's the only ones you can do in your calculator. That's log base 3. Can't do it, but I'll show you later on how you can change it to something you can type in. E raised to the x minus 1 power equals 9. And again, all we're doing is rewriting this in logarithmic form. So that'd be log base, anybody? So don't put log, right? Instead of log base e, put ln. That's log base e. Log base e of 9 equals x minus 1. I know that's not solved completely. We'd have to move the 1 over to actually solve that, but all it says is write it in logarithmic form. You didn't have to actually solve it. F raised to the negative 1. I wonder what's that. That's, if you don't remember, that's F inverse. Going back, and that's the way pre-calculus works. They kind of introduce a topic at the first, and then they show you a new general topic, and then they bring that same topic back in over and over. One of those topics is inverses. Make sure that we know how to find inverses. To find F inverse, here's all you do. X and Y, you switch them. Change every X to Y, change every Y to X. So here we have Y equals 1/2 times 6 to the x minus 3 power. So many people are tempted to do 1/2 times 6. Don't. Can't. 6 is being raised to the x minus 3 power. 1/2 is not. Okay? If you multiply those together and turn it into 3, all of a sudden the whole 3 is being raised to the x minus 3 power. You cannot multiply those. So in order to find the inverse, we're going to turn y into x. We're going to turn x into y. That is the inverse. Can't stop there. We want to solve this thing for y, but that is the inverse. Now trying to solve it, trying to get y by itself, what would y'all move first? We'll work this one together. The 1/2. 1/2 is being multiplied by this whole thing, so how do I divide? Or excuse me, how do I move it? I divide. How do you divide? That is a good question. Multiply by the reciprocal. So we're going to turn this into 2x. 2x equals 6 to the y minus 3 power. Now here's the issue. And I'm glad we're doing these before we're going into equations because this will help you on equations. There's nothing else I can move. I can't move the 6 because you got that y minus 3 just floating in there. And we've never seen anything like that. So we've got to figure out some way to get y by itself. When we get into equations, this will always be your rule. Move everything that you possibly can first, Once you get stuck, change forms. This is exponential form. Once you get stuck, change it into a logarithmic form. Help me. Log, base, it's backwards, isn't it? You're used to seeing 6 to the power over here. Don't get thrown off by that. Log base 6 of 2x. The stuff on the other side. Log of this base, all of the stuff on the other side is equal to y minus 3. You see now that we've nearly got y by itself. Once you get stuck, change forms. The last step is I just need to move my 3 over. Since it's minus 3, I'll change it to plus 3. You have the option, if you want to tack it on the end, just don't do this. Log base 6, let's be a 6. Log base 6 of 2x plus 3. Do not write it like that. Does everybody understand why? I don't know if I'm taking log base 6 of 2x. I don't know if I'm taking log base 6 of 2x plus 3, part of it, whole thing, just the 2. Make sure that whatever you're taking the log of, which is just the 2x, is in parentheses. It's okay to write it like that if you're going to put that in parentheses, because you're only taking log of 2x. Then that plus 3 is tacked on. Or if you just want to be certain, you can put the 3 first, because then there's no confusion at all. I do want you to know this, though. Even if the 3's first, it could be written at the end. That would be a vertical translation there, that plus 3. Whether it be at the first, whether it be at the last, it's vertical. Okay. So that is, now that you have y by itself, you can actually erase it. And we just found f inverse. Or f inverse of x. Reminder of what an inverse is. If you plug something into your original function, 3 would be easy. If I plug 3 in, 3 minus 3 is 0, 6 to the 0 is 1, 1 half times 1, I get 1 half. That means that in my inverse down here, if I plug in a half, I should get 3, and you can try it, I will. Okay. Solving equations. Solving equations. And we're going to start with some basic ones. These will be pretty good. Log base 3 of x equals negative 2. I can't move anything over. There's no plus minuses. There's no multiplication. If you had like 5 times this, you can move the 5 over, but there's nothing that can be moved over, so the only option you have, change forms. Sometimes it's as simple as that. Help me change forms, Drake. 3 raised to the equals x is by itself done. All right. Of course, we do want to simplify that. 3 to the negative 2. Anybody? A 9. Good job. So x is a 9. Again, same thing. Log base x of 5 is equal to 2. Austin, help me rewrite it.
X squared equals 5.
That's it. That's all that equation is. X to the second power equals 5. We solve that. To get rid of a square, we do plus and minus. Don't forget that, the square root of 5. I don't know if you remember, though, the base of a logarithm will always be positive. Okay, you're not going to have a negative base. Let me go back. Let me scroll back and see if I can find that slide again. That's a good while back. Right there. For a greater than 0, and the a was the base, your a will always be bigger than 0. So with that said, not positive, negative 5, you can just leave that as positive 5. Because the base of a logarithm, you see x as the base, is always positive. And you can check that, the square root of 5 to the second power is 5. That checks out. Moving on. Next one, 5 to the x power equals 9. Solving this equation. Bless you. And you know what? I'm going to go ahead. I'm going to get ahead of myself. We're going to go ahead and show you how to type this in the calculator, because you're not going to be able to solve this if you don't. You're not going to be able to get a decimal answer. So here's your first real log equation. First step, there's nothing I can move over. If I had it 3 times, yeah, I can move the 3 over. I could divide by 3, but can't do it on this. So The only thing that I can do is change forms. This would be log base, good, of equals. So x is that. Well, that's great. What is that? Well, if you remember yesterday, the way you would solve that is say, okay, 5 to some power is 9. That doesn't help because that's what the equation was, right? Here's how you can type this into a calculator. Like I said, I'm getting ahead of myself, but that's okay because we're going to discuss it in just a second anyway. It's called the change of base formula. If you want to take a logarithm, and don't ask me what words, pretty complicated. If you want to take a logarithm and you want to change it to a different base, this log base 5 of 9, you could rewrite that with any base that you want to by doing this. You could do log base 3 of 9 divided by log base 3 of 5. You could do log base 4 of 9 divided by log base 4 of 5. You could do log base 9 of 9 divided by log base 9 of 5. You can turn it into any base that you want to by doing the log of this number divided by the log of this number. It doesn't matter what base you use, it works out the same with any of them. So with that said, what base should we use? You have two pretty good options. Base 10 or base E. You're going to get the same answer either way. So what I would do to type this into my calculator, I wouldn't use those bases. I would say that log base 5 of 9 is equal to the log of 9 divided by the log of 5. Or the natural log of 9 divided by the natural log of 5. Let's try it both ways and just make sure we get the same answer. I don't know why it's so hard to turn that up. Second quit, clear. Okay, here we go. Log 9. Make sure you close parentheses. A lot of people get into a bad habit of not closing it. If you don't close parentheses on these, you miss them. Log 9 divided by log 5, enter. Natural log 9 divided by natural log 5, enter. Your answer is 1.365. So what that tells you is, I'm going to round that to 4 decimal places. X is about 1.365, what? 9? 2. 1.3652, is that right? If you raise 5 to the 1 point, and that kind of, you had an idea about what your answer would be, because 5 to the first power is 5. 5 to the second power is 25, so it's got to be somewhere between 1 and 2. Well, what is it? 1.3652. On your ACTs, you are not required to carry a calculator. So how are they going to leave your answer? That or that. They're not gonna leave it as probably log base 5 of 9. They're gonna leave it as either this or this. They're gonna make you know in order to type that into a calculator that you would do change of base formula. You'd have to do one of those. Another, probably the easiest ones of them. Since logarithms are one-to-one functions, meaning each x has a unique y, each y has a unique x. Here's what you can do. Let me relate this to a different type of formula or a different type of equation. X divided by 3 equals 5 divided by 3. What's X? 5. Do the 3's matter? No. What's the only thing that matters about the 3's? They're the same. Now, if you had X over 3 and 5 over 6, yeah, they matter. Okay? Since the bottoms are the same, the tops have to be the same. How does that apply to this? The natural log of something equals the natural log of something. Somebody go to the next step for me, please. Does that make sense? Why? The natural log of one thing equals the natural log of something else. Since it's a one-to-one function, that you don't have to know, but you can dump your logs. Dump your logs. Here we go. So x squared equals 3x. In order to solve, it's quadratic. Move everything to one side. So we have x squared, positive 3x turns into negative 3x. We have factoring. And these are the ones that people miss because everybody's saying, well, how do you factor that? There's no constant term. Anytime there's no constant term, pull an x out. You have two answers, x equals 0 or x equals 3. Always check. Anytime you have domain restrictions, always check for extraneous values. You have extraneous values here. You cannot take the log of 0. If you plug 0 in, natural log of 0 equals natural log of 0, you cannot take the natural log of 0. That's not in its domain. The domain of natural logs or domain of any logs is greater than 0. You can take the log of 0.1, but you cannot take the log of 0. So therefore, you dump 0, x equals 3. That's the natural log of 9 equals natural log of 9. That works out. Next problem. Use a calculator to find the value of x rounded to the 4 decimal places. 10 to some power is 50. What two numbers are my answers between? 10 to the first power is 10. 10 to the second power is 100. So is it 1.5 because it's, no, it should be pretty close. It's kind of in the middle, right? But it's not linear. This is not a linear function. 10 to some power is 50. We can't move anything over. If you move the 10 over, the x is floating in the air. Can't do it. So we're going to change forms. Log base 10, right? You don't have to put it. You see what makes this problem a little bit easier? Log base 10 of 50 equals x. Somebody type that in. You don't have to do change of base on it because it's just plain natural. In common law, excuse me.
1.698.
1.6989. Which is pretty close to the middle. You expected it would be. Next one, 2e to the 0.5x equals 6. Again, now on this one, I've got stuff I can move first. Take the 2, move it over. We have e to the 0.5x equals 3. We're going to change forms because there's nothing else I can move over. Log base, what, Josh?
Log base E.
Good. So we're going to put L in. And they gave you these easier problems here before they're going to give you the change base formula, which I've already talked about, because on these you don't need the change base formula. So Ln of what, Josh?
E.
So, no, you got log base E of 3, good, equals the 0.5x. And if you want to go ahead and solve for x before you type it in, you can just get it all at once. To get rid of the 0.5, you're going to divide this whole thing by 0.5. So x is equal to the natural log of 3 divided by 0.5. So x is about, tell me when you get it. Anyway.
0.1972.
Like that? 2.1972. So now let's take what we just learned and apply it. We're going back and talking about the exact same stuff we did at the first chapter, that compounding interest problems. And the reason we're doing that now is because before we were finding A in continuous and in the, what do we call it, the other compounding problems where you're compounding semi-annually, monthly, daily, whatever. But now you're going to be looking for other parts, like how long will it take? What's the interest rate you're going to have for this to happen? First problem, if $8,000 invested, compounding continuously. Since it's continuous, here's your formula, A-PERT. Reminder, you use A-PERT when you have compounding or continuous compounding. You use this other formula when you have monthly, daily, whatever. So it says if $8,000 is invested, that's your principal, at 9% compounded continuously, so e to the 0.09, how long will it take? We don't have a time for the investment to grow to 20,000. So you see now why we needed these logarithms before we could solve these type of problems. First step, take your 8,000, let's move it over. Divide by 8,000. I think 3 of those zeros will cancel with 3 of those. You don't have to reduce it because you're just typing it in your calculator, but if you want to, just make it look better. Divide by 2, divide by 4, that's going to be 5 halves. So you have 5 halves equals e to the 0.09t. Raj, is there anything else I can move over? Can I move over part of this exponent here? There's not, is it? When there's nothing else you can move over, change form. So Raj, help me do that. Let me scroll up a little bit. Log base what? Log base e. So good job. Ln of equals. So you would type that into your calculator as, got to divide to get rid of that, the natural log of 5 halves divided by 0.09. And that would tell you your t. So t is about 10.181. Is that what y'all got? Years. These formulas are always in years. Now let me show you some extra information. That's your answer. I'm good with that. I want to know, and this kind of helps you with something we're going to do later on in trigonometry. That's great, 10.181 years. But if somebody asks you how old you are, usually you don't say 10.181 years. If somebody, especially when you're talking about like young kids, babies, stuff like that, you divide it into years, months, or whatever. It's, well, he's 14 months old, he's a year and 3 months, or whatever. Let's change that into months. Again, this goes back to more of a basic math type problem, but I want you to understand how to do it for, like I said, for when we get to trigonometry, we're going to change degrees, minutes, seconds. So change stuff into degrees, minutes, seconds. It's the same process. 0.181 years. 181 thousandths of a year. How many months is that actually? Well, 1 year. 1 full year is 12 months. This is a portion of 12 months, right? So how do I find out exactly how much that is? A portion of 12 months, what's the word of me? Multiply. You just multiply the two together. 0.181 times 12, and somebody tell me what you get. 2.172. So it said. So how many months do you have? 2 full ones. But then you have another portion. And if you wanted to, you could take that other portion and say, okay, here's your only issue though, is there 30 days a month or is there 31 days a month? It really all depends on what you're talking about. So that's one way to do it. You could turn this into, well, it's closer to 2, so it's about 10 years and 2 months. Or you could have done it like this. Let's go a different direction with it. You could say 0.181. Let's turn that into days then. Instead of months, let's do that as days. So 0.181 of 365 days. Because that's a portion of a year, right? So let's do the 0.181 times 365, and we can break it down a lot like this. I mean, what's that when you multiply it out?
66.065
days. So that's 66 full days. What can we do with the 0.065? Because that's a portion of a day. It's a little bit over 66 days, 66.065 days. We'll take that portion and say, well, in a day, I've got 24 hours. So you could do the 0.065 of the 24 hours. And just this will be the last one we do. What is 0.065 times 24? 1.56. So what said. And you see where I'm going with this. You could take that now. That's 1 hour and a little over. So now you could take the 0.56 and multiply it by 60, and that tells you how many minutes. And then you'd have minutes with a little bit left over. And you could take that and multiply it by 60 again to tell you how many seconds. So you could actually break this down to years, days, hours, minutes, seconds, milliseconds. You can go as far as you want to. So in this case, that would be 10 years, 66 days, 1 hour, and like I said, you can continue on there. And those do correspond. Whoops. because 10 years and 2 months, yeah, it was 10 years and there's 2 months, a little bit over 2 months. Okay. Next problem. Oh, no, just kidding. 4 logarithm rules. I was wanting to make sure to get these down. Awesome. 4 basic rules of logarithms, and you're going to notice a little overlap here. Guys, a logarithm is an exponent. An exponent is a logarithm. Same thing. And those same rules that you had for exponents, x squared times x to the third equals x to the fifth. To multiply exponents, you add, or to multiply the same basis, you add the exponents. You're going to see the same kind of thing going on here, except for with logarithms, we kind of write it backwards. We're flipping everything around, so it's going to be similar to the rules, but not exact to the rules. So here we go. Your first rule of logarithms states, and this looks confusing, so let me give you an example. To add 2 logarithms, let's say, and this goes for any base. I'm going to do it with a base 10 just so I don't have to put a number down here. The log of 3 plus the log of 2. To add 2 logarithms, you multiply the arguments. The log of 3 plus the log of 2 is equal to the log of 6. Now, what's that related with? Exactly what I just showed you. When you're multiplying, you do what with the exponents? You add them, right? Well, logarithms, again, same thing, backwards. To add 2, you multiply. You can do backwards. You can go backwards with that. If you had the log of, let's do a natural log here, just so. If you've got the ln of xy, if you have a log of things being multiplied, you could separate those by adding. That's kind of like factoring. That's your first rule of logs, called the product rule. So therefore, log base 3 of x plus log base 3 of 6. Parker, combine those two for me. It would be log base 3 of, that's it. To add 2 logs, multiply the arguments. To add 3 logs, multiply the arguments. Natural log 3, natural log x squared, natural log y would be the natural log of
3x squared plus.
No. To divide a log, to subtract 2 logs, you divide. To add them, you multiply. To subtract them, you divide. Makes sense. The log of 6 minus the log of 2 equals the log of 3. To subtract 2 logs, divide the arguments. Yes, sir. Yeah, go ahead. Works the same way with if you had the log, let's do natural log. If you had the natural log of x divided by y, and you wanted to separate them, that'd be the natural log of x minus the natural log of y. So, log base 3 of 24 minus log base 3 of 4 will be log base 3 of 6. 24 divided by 4. We're good? Natural log of x to the 6 minus natural log of x squared. It will be. It's the natural log of x to the 4th power. Let's show our steps with that. That's the natural log of x to the 6 divided by x to the 2nd. And we can clean that up with our exponent rules, which is the natural log of x to the 4th power. The power rule. Here's the clean, simple version. Now, you might be able to tell from this what the power rule states. Notice you've got an exponent up here, and this is an odd rule. This is a really weird rule. But if you have the log, you use it a lot. If you have the log of something to a power, the power rule states that this power can be moved down front. The log of 3 squared is equal to 2 times the log of 3. Anytime you have the log of something to a power, you can move it down front. Here's your proof. The log of 10 squared. That's the log of 100, right? Which should be 2. Can I take this down front and write it as 2 times the log of 10? What's the log of 10? 2 times 1 is 2. Same answer. Anytime you have something to a power, that power can be moved down front. Where you're going to use this a lot is when you're solving equations, the log of x squared. You could take that 2, move it down front, all of a sudden it's turned into a linear equation. Okay. So therefore, the log of 3 to the 8th power is, I'm not going to insult your intelligence, 8 times log 3. Just move it down front. Here's a good one. The log of the square root of 3. How can I rewrite that?
1/2 log 3.
1/2 of log of 3. Square root of 3 is 3 to the 1/2 power. 3 to the 1/2 power, that power can be moved down front. Okay. Okay, here we go. Rewrite each expression, and these require a little bit of thought. Rewrite each expression in terms of log of 3. Any ideas on how to do that one? There's 2 methods. You can use either your quotient rule that we just discussed, or you can use the product rule, or the power rule that we just talked about. Use quotient rule. The log of things being divided can be split into the log of 1 minus the log of 3. But clean it up as much as you can. What is the log of 1? 0. This states, there's a 10 right here, right? 10 to what power equals 1? That'd be 0. 0 minus the log of 3 would simply be the negative log of 3. And when it says write it in terms of log of 3, look, log of 3. You've got other stuff mixed with it, but log 3, not log 1/3. We've got it in terms of log of 3. Now, you'll know the easy way to do that. 1/3, is that not 3 to the negative 1 power? And the rule that we just did says if you've got something, a log to a power, of something to a power, you can just bring the power down front. Same answer. Negative log of 3. Either way is fine. Rewrite log 27 in terms of log of 3. Rewrite natural log of 27 in terms of natural log of 3. Because here, for some reason, I know I have memorized what the natural log of 3 is, not really. But let's just say I have memorized what the natural log of 3 is, and I have a basic calculator. I don't have a scientific calculator, so I can't type it in. So how could I find out what the log of 27 is? What's this? Is 27 not 3 times 3 times 3? Right. So if I know what the natural log of 3 is, don't I know the natural log of 27? Power comes down front. That is 3 times the natural log of 3. So if I know what the natural log of 3 is, I can just multiply it times 3, and that's the natural log of 27. Good? So if you know, for some reason, you want to memorize them. If you want to memorize the natural log of 3, all of a sudden you know what the natural log of 3 is, you know what the natural log of 9 is, you know what the natural log of 27 is, along with a whole other list of things like, you know, the natural log of a third. Because the natural log of 1/3 would just be the negative of the natural log of 3. That's probably just it. The inverse rules. And these are pretty simple rules. You come across these a lot. These are one of those, again, run up on it on a standardized test, and it looks really hard to begin with. My biggest thing to say here is don't worry with the y's, it just is. I can go through the proof of y, especially with the first one. The first one we'll go through the proof of it, but it just is, okay? Well, let's do some simple ones before we go through those. Your first rule states that if you have a logarithm with a certain base, let's say 5, and you notice that you have a here and a here, let's say log base 5 of 5 to the 2nd power. If your base and your argument are the same number, your answer is just your exponent. If your base and your argument is the same number, your answer is just the exponent. Why? You tell me. Use your third rule of logs. What can you do with this 2? Put it on the front. Is that always true? Can I always just put it on the front? Yeah, that's your third rule of logs. Look what you're left with. If your base and your argument is the same number, what is log base 5 of 5? 1. What's log base 6 of 6? 1. So do you see why your answer will always just be whatever in that power is? So this next problem, look at it. E raised to the, no, that's not good. There we go. Log base 7 of 7 to the 2x minus 1 power. Base and argument's the same. What's your answer? Anytime you're basing your arguments the same, your answer, it reduces to whatever that exponent is. Any questions? The second one, like I said, I'm not going to go through the proof of this one. Second one's a little bit more detailed proof. If you have some, let me change colors. If you have some number, let's say 5, raised to the log with that same base of x. Bases are the same. Just take a stab at it. What do you think is going to be the answer? Same as the first, the x. Okay. Now, if you want to go through the proof, if you set this equal to y, I'll leave that with you. If you want to set it equal to y and actually change that from, this is an exponential form. If you want to change that to a logarithmic form, can't handle it. I've got to do it. You get log base 5 of y equals log base 5 of x. Remember those log? You're left with this y, your answer, you'd simplify into just whatever x is. So with that said, anytime you have a base raised to a logarithm with the same base, what's this going to simplify into? Because the base here, natural log, the base there is e as well. What will that all simplify to? Just x squared. 5 raised to log base 5 of x simplifies to just x. 6 raised to log base 6 of smiley face. The answer is smiley face. Okay. If your bases are the same, pretty much dump everything else, your answer is the argument. Rewrite each expression in terms of log 2, log 3. We have log 6, and like I said, for some reason, let's say that you have memorized what log 2 is and what log 3 is, and you want to know what log 6 is. Can we use log 2 and log 3 to find log 6? Yes. Try to manipulate this, change it somehow to where we're dealing not with 6s but 2s and 3s. Well, how do you change a 6 into 2 and 3 stuff? Log of, what's the relationship between 6, 2, and 3? Well, yeah, 2 times 3, you're getting ahead, right? Which would be, now that I've changed 6 into 2 times 3, we can use that first rule. We've got 4 of them now. Product rule says the log of 2 times 3 is the log of 2 plus the log of 3. And we've done what it asked us to do. Rewrite each expression not in terms of 6, log of 6, but in terms of log of 2 and log of 3. So there's your log 2, log 3. So if you've got memorized what the log of 2 is and what the log of 3 is, you take those two answers, add them together, that's log of 6. Let's do another one. These, to me, these are like puzzles. These, you've got certain math problems that's just like, trying to figure out how to get from point A to point B. These are puzzles. Because now you've got log of 16 thirds. Now you've got to change that into 2s and 3s. What's the relationship? Well, we got a 3. We're good with the 3. So how do we get from 16 into a 2? What's the relationship between 2s and 3s? Is there any way we can take 2s and 3 and turn them into 16s? 2 times 2 is 4, right? 2 times 2 times 2. 2 to what power is 16? 2 to the 4. That's 2 times 2 times 2. Yeah, we can turn 2 into a 16. So I'm going to rewrite this, and it's okay that I have another power. I'm going to write this as the log of 2 to the 4th power over 3. And I'll show you why in a second, because that 4 is not going to be a factor. Anytime you have division, we're going to rewrite it as log of 2 to the 4th minus the log of 3. Everybody good with that? Division turns into subtraction of logs. What can I do with a 4? Put it in front. 4 times log of 2 minus the log of 3. So once again, if you have memorized what the log of 2 and log of 3 is, you can take 4 times whatever that log of 2 is on a basic calculator. Minus whatever the log of 3 is, that's the log of 16 thirds. Good. Log of 1/3, we've already worked that one. That's 3 to the negative 1, bring the negative down front. That's negative log of 3. Now, it says terms of log 2 and log 3. You don't have to use both of them, just either or and. See how many more of these we got. We'll work this next one, then we'll stop for the day. Then we'll go into change of base tomorrow. Or Monday, excuse me. Write natural log of 45 in terms of 3 and 5. Any ideas? Yeah, you're going straight to the answer. That's perfect. It'll be 2 times log of 3 plus log of 5. But what he did he did the natural log of 9 times 5. Well, 9, that's 3 squared, right? So we've turned it into 3s and 5s. Because that's the natural log of 45. And then you use your rules. Those 4 rules, log of things added will be the natural log of 3 squared plus the natural log of 5. Bring the 2 down front. 2 times natural log of 3 plus natural log of 5. Test.